able to fulfill the properties of functionally complete or universal gate, and how we can design the NAND gate, AND gate, OR gate with the help of NAND gate, or directly we can convert to the NAND gate or NOR gate. Okay, that particular part we are discussing. Now, before going to design the combinational circuit, okay, so we know the minimization technique. So already you know there are two types of minimization technique. One is based on the Boolean expression. We are using some rules and axioms. We can minimize that particular expression. But thing is that if we are using the axioms and rules, sometimes what happen? Suppose X student, suppose some particular student, they are efficiently use the rules, some particular axioms and the Boolean algebra rule. That time what happens? Suppose they are using the two terms and the two literals. The same expression some other student also doing, and he is using some particular rules and axioms. He is getting three terms and the two variables. So obviously first one is very efficient because they are using only two terms. Though second one using two variables, but what happen? Expression coming in the form of three terms. So second one, when we are comparing, that time what happen? Second one is not, it is not efficient as compared to the first one. But second one also properly use the rules and axioms, and first one also properly use the axiom and rules. But what happen? First one more intelligently use that particular rules. So what happen? His answer is correct. So lot of their confusion is coming when we are using the axioms and rules. Okay, and when we are, because what happen? When we are talking about the large circuit, our expression also very large. That time what happen? Some particular problems are coming. Then suppose what happen? You cannot efficiently use the rules and all those. You forget the rules or you are not properly used. So that time what happen? Some particular technique we are using. The first technique is called a Purnam. It is what? It is simply Karnak map. Karnak map. Okay. And shortly it is use a K-map. Okay. But when we are using K-map is nothing but a one type of graphical representation or pictorial representation. Are you getting my point? But here some particular advantages are there and also disadvantages are also there. Okay, that particular part we will discuss later. But what happen? When you are minimizing the Boolean expression with the help of K-map, that time what happen? Whatever expression you are getting from the K-map, you can ensure that that particular expression is the accurate minimized. That is the advantage. Okay. Sometimes what happen? Whatever the expression we are getting from the K-map, again we are using some particular axioms and rules we can try. But what happen? We can assume that, and it is already maximum cases it is already proved that whatever expression we are getting from the K-map, that particular already is the minimized. But when you are using the, if you are not properly use the axiom and rules, if you are using the from the Boolean expression, that time whatever expression you are generating from the axioms and rules, you cannot say. If you are properly used, then it is no problem. If you are not properly used, then what happen? Your expression is not a accurate minimized form. Okay. So that is the advantage when we are comparing K-map with the normal Boolean, when we are using the Boolean rules and all those axioms. Okay, when we are minimizing the expression. Okay. But the disadvantage also there. Okay. So what is K-map? Okay. So there are a lot of things are there. You see, suppose I am discussing one way. So main purpose of this particular K-map, we are using either it is subform, it is postform. Okay, we can use the K-map. So that means what? The meaning is that K-map is not restricted only the subform. K-map also, it is also we can use in the postform also. And also providing the alternative way of simplify the Boolean function. Okay, so what is the meaning? Boolean function also we can realize or also simplify with the help of Boolean expression rules. Okay, axioms and whatever we are discussing the earlier rules. If we are using the rules, that time also simplification is possible. But what happen? Another way also K-map what happen? It is the mainly using the simplified Boolean function. Second point, see, instead of using algebraic simplification technique, we use a pictorial representation of the function. So some particular graphical from the graphical representation, we can construct the KMF, and from that particular graphical representation, we are getting the Boolean expression based on which are related with some particular Boolean function. Okay. But remember what happened when we are using the n variable function. Suppose n variable means what? If that particular function, if we are using 3 variables, that time what happened? N value equal to 3. When we are using 4 variable, that time what happened? It is 4 variable function. When we are using the 5 variable, that time what happened? It is called a 5 variable function. So what happened if we are using 3 variable, that time 2 to the power n cells are possible. That means if 3 variable, that means what? 8 cells are possible. If we are using the 4 variables, that time 16 cells are possible. Sorry. If we are using the 5 variable, that time 32 cells are possible. How we can design the cells, that particular part, you don't worry, that particular part we will discuss later. So see here, these particular 3 points are very important. Adjacence. Adjacent means what? Neighbor cell. If adjacent 2 cells differ in only one variable. When we are comparing the 2 cells, that time what happened? Only one variable is different. That means different. Other variables are same. Variable means what? Literal. I am talking about the literal. Okay. So when we are using the 4 cells, that time what happened? Only 2 variables are differ from each other. And similarly, in generalized form, if we are using 2 to the power m cells, that time what happened? M variables are differ from each other. Okay. Now, how to make the KMF? So you know this particular concept. We try to group 2 to the power m adjacent cells based on the m value corresponding to the true mean terms. Based on the true mean terms, we can group this particular 2 to the power m adjacent cells. Some particular rules are there. Okay, that particular part I will discuss later. We have a loop for adjacent squares having ones. Okay, so that means what? When we are in mean terms, all the where 2 mean terms are there, that particular cell we are denoting as a 1. But when we are considering the max term, that time what happened? For true max term, we are using zeros instead of ones. But for the time being, don't confuse about the mean terms and max term. Just I'm talking about in the form of soft. Okay, so here I'm using the mean term. When the 2 mean terms are there, that time what happened? That particular cell we are denoting as a 1. And after that what happened? Mean terms adjacent to each other and combine them to form a large square and to eliminate some variables. So see here some particular concept we are using. So large cell means what? Always what happen? When suppose what happen here 2 cells are there. When we are combining 2 cells, and when we are at the same time, if we are combining the 4 cells, which particular group is large? 4 cells are large because there are 4 cells. But when we are considering the 2 cells, it is very small. It is constructing very small group. Okay. When 4 cells are there, that time what happened? How many variables are different? 2 variables are different. That time what happened? When 2 variables are different, that time what happened? We can eliminate many variables as compared to the 2 cells. So always remember, when we are constructing the KMF and when we are using the technique of KMF, that time what happens? Your main objective is that to make the large squares. If it is not possible, then it is okay. But if it is possible, then your objective is that you can construct the large square so that there are many cells are included. That means neighboring cells are included. You cannot take any other XYZ cell. You can consider only the neighbor. There are some particular rules are there. That particular rules I will discuss. Okay. But problem is that in KMF, I have already told some particular disadvantages are there. In this particular KMF, only suitable for very efficiently we can apply for 4 variables. 4 variables means what? Where the function have only 4 variables. But when we are using more than 4 variables, suppose we are using 5 variables, 6 variables, 7 variables, that time what happens? This particular pictorial representation is very complex. And it is very difficult to extract the expression. It is not like that it is not possible, but it is very difficult. When we are talking about the 8 variables, And for 8 variables, when we are constructing the KMF, that time what happened? That particular KMF is also very large, many number of cells are there, and how we can make the group, it is very complex. So people are not using KMF when it is 5 variables. Okay, it is also possible. Okay, but when it is going more beyond than 5 variable or more than 5 variable, that time what when people are avoiding this particular KMF technique. Okay, for that particular purpose, there are another technique. It is called a tabular method or Queen exclusive method. But that particular method also has some particular disadvantage. Okay, that particular part also we'll discuss later. Okay, now any doubt from this one? Any doubt?
No, sir.
Okay.
No, sir.
No, sir.
Okay. Now we are going to the next slide. Now see here, different type of KMF we are using. So we are not going to the 5 variable. Okay, I'm one particular example I will discuss how to make the KMF for 5 variables. But remember, 5 variables we are not generally using when the function have a 5 variable. Okay, we can use, but generally we are not using. Okay, so we are discussing our main concentration only 2 variables, 3 variables, and 4 variables. Now, how we can design the 2 variable? So 2 variable means what? 2 to the power 2. That means m value is 2. So 2 to the power 2 means what? The equal is 4. So here 4 variables are there. This one is the 1 variable. Okay. So this one is the 1 variable. This one is the 1 variable. No, sorry. This one is the 1 cell. This one is the 1 cell. This one is the 1 cell, and this one is the 1 cell. How many cells are there? 4, because it is only 2 variables. So 3 variables means what? 2 to the power 3, here m equal to 3. So how many? 2 to the power 3 means 8. 1, 2, 3, 4, 5, 6, 7. Okay. And when we are talking about the 4 variable, 2 to the power 4 means what? 16 cells are there. This is the 1 cell, 1, 2, 3, 4, something like that. Up to here is a 16 cell. Okay. And what is the meaning of neighbor or adjacent? So when we are considering this particular cell, what is the adjacent? This one or maybe this one, not this one. Okay, because this is the diagonal. So what happens when we are neighbor? Either we can consider this one or we can consider this one. Vertical and horizontal is possible, but not a diagonal. This particular cell we are not considering as a neighbor of this one. But when we are considering this particular cell, that time what happens? This one is the neighbors of this one. Okay, so that is the concept of neighbor. Okay, but apart from that, there are some particular rules are there. I'll discuss. Okay, after a few minutes, then you can automatically understand. Now, main thing is that how to construct this particular table. So 2 variables means what? Here we are using only A and B. So here what happened? This is the means what? This particular 0, 1 is lies in the B, and this particular vertical 0 and 1 lies in A. Okay, it is, if we are considering this one, that time what happened? This one is, if you are considering this one, what is the value of AB? AB value is 0, 0. When we are considering this particular cell, A value is 0 and B value is 1. That means 0, 1. When we are considering that this particular cell, A value is 1 and B value is 0. That means what? It is the 1, 0. And when we are considering this particular cell, A value is 1 and B value is 1. So this one is what? 1, 1. Similarly, this one, when we are considering, because this is the 3 variable, so this side we are going in sequence from A, B, C. We are going this way, A, B, C. Here we are not writing, don't use some particular books, it is mentioned that time what happened, if you are using A, B, then also correct, A, B and C, but this particular table is in the form of defined form. So you can maintain always this particular template. Okay, and Maurice Mino also and many other books, this is the standard template. So what happened when we are talking about the 3 variable, that this particular part we are considering only 1 variable, and this particular part we are considering the 2 variable. So here 2 variables is present. Due to this particular reason, here we are using 2 bits. Okay, and here we are using only 1 variable. So what happened? Here we are using only 1 logic. Okay, but see, if we are using the 4 variable, here also A, B and C, D, here also two logic values are there, and here also 2 logic values are there. Okay, now see, when we are using 3 variables, okay, see here, when we are using the when we are using the, see here first part, adjacent of two cells. When we are comparing with the two cells, that time what happened? Only one variable is different. Okay. Now meaning is that it is that see here if you are denoting the decimal number here or min terms here, that means what? This one is 0, this one is 1, this one is 3, this one is 4, this one is 5, this one is 6, this one is 0, 0, 1, 0, 1, 2, 3. Okay, this one is 2, not a 5. This one is 2. Okay, this one is 2, and 0, 1, 2, 3, this one is 4. Okay, and this one is 5, and this one is 6, and this one is 7. So how we can assigning the logic value? See here, if we are considering this particular 0, 0, that means what? It is produced 0. When we are writing 0 A, B, C, we are read A, B, C, this particular form, A, B, and C. So that's why we can also read the logic value this particular form. So when we are talking about this particular cell, what is the binary value representation of this particular cell? 0, 0, 1. Yes or no? This is the 0 and this is the 0, 1. So this one is A and this one is BC. Okay, so 0, 0, 1 means what? It is 1. And 0, 1, 1. 0, 1, 1 means what? This one is 3. And 0, 1, 0 means what? This one is 2. This one is 2. And 1, 0, 0 means what? It is 4. 1, 0, 1 means 5. 1, 1, 1, 1, 0 means what? 6. And 1, 1 means 7. Now you are asking, why sir 0, 1? Why it is not a 2? Because if we are going sequence wise, if you are read from horizontally left to right, then it is 2. Then why we are using 3? Okay, for a time being it is 3 or 2, it does not matter. But whatever we are assigning, that particular two min terms are coming in the decimal form. So 0, 1, 1 means what? It is 3. But why 0, 1, 1? Why we are not putting here 1, 0? If you are putting 0, 1, 0, instead of 1, 1, if you are using 1, 0 here, if you are inserting this way, okay, and this way, okay, and we are inserting this way, that time what is the problem? Why we are not using this one? Meaning is that, suppose when we are talking about this one, this particular cell, so this particular cell neighbors is this one. So what is the value of this one? This one is value is 0, 0, 1. If we are considering this particular cell, I am talking about this particular cell. Okay, so this particular cell, see here 0, 0, 1. Okay, if we are comparing two cells, okay, two neighbors. So what happened? Instead of 1, 1, suppose this one is moved to this one. That time what happened? This one instead of 1, 1, here it is 1, 0. So what happened? This one is 0 is already fixed. So 0, 1, 0. 0, 1, 0. That time what happened? If we are considering this particular first row, if we are considering as A, second row we are considering as a B, suppose third row we are considering as a C. Here three variables are there. So when we are comparing this one and this one, see 0, 0 is same. 0, 1 means what? It is the difference. Okay, distance is what? When we are comparing this particular two binary set, distance is 2. Okay, so this one is defined 0, 1, and last one also defined. Here it is 1, first one is 1, and this one is 0. So how many variables are different? Two variables are different. But here rule is that only one variable is different. For that particular purpose, to maintain the properties, instead of 1, 0, we are putting here 1. Okay. Okay.
Yes, sir.
Yes, sir. So when we are using the 4 variable KMF, that time what happened? We are using this particular part, this one 0, 0, 0, 1, 1, 0, and this one 0. So what happened? How it is representing in the min terms form? This one is 0. But remember, please use this particular template. Don't use the other template. Some particular books have a different template, but generally people are using this particular template. Is very easy. Okay. So 0, 1, this one is what? 2, this one is 3, this one is 4, this one is 5, okay, this one is 6, this one is 7, this one is 8, this one is 9, this one is 10, this one is 11, 12, 13, 14, and 15. Now you combine the sequence. When we are combining 1, 1, 0, 0, 1, 1, 0, 0 means what? It is always 14. When we are comparing 1, 0, 0, 1, 0, 1, 0, that time what happened? This one is 11. Yes, tell me.
Sir, in the last cell, should it be 8, 9, 11, 10?
8, 9, 8, 9, 8, 9, 11, 10. 8, 10. No, why I am not using, because see here, why this is not a 8, 9, 11, 10. 8, 9, 8, 9, 11. Yes, 8, 9, 11, 10. This one is 8, 9, 11, 10. Yes, it is correct. Okay, 1, 0, 0, 1, 2, 3, 2, 3, yes. 8, 9, 11, this one is there. Yes or no? 8, 9,
Yes, sir.
8, 9, this one is 11, 10, 12, 13, 14, 15. This one is 8, this one is 9, this one is what? 11, not a 10. Remember, this one is 11 and this one is 10. Okay, so this way we can get the mean terms. Now we know what is the construction procedure. Okay, this is the construction procedure. But how we can apply, how we can simplify the Boolean expression with the help of KML. Okay, so that particular part, suppose I am taking one example. From the example I am explaining, if any doubt, then you can again ask me. Suppose what happened? Suppose this is the example. Reduce the expression, here it is a bar b bar plus a bar b plus ab using KML. It is very simple. Okay. Now what happened when you are getting this particular expression, that time what happened? Your function must be a two variable, because here c is not present in any particular term. So obviously what happened? We are getting that the only two variables we are using, that is a and b. Now what happened when we are using the KMF? That means when we are seeing this particular expression, then automatically we know, yes, oh, this one is not a soft form, this one is, it is not a post form, this one is the soft form. And always remember, when we are using the KMF, any particular expression, we are getting the mean terms. We are extracting the mean terms from the expression. Okay, so when we know this one is the soft form, because here it is in between this particular term, between the variable we are using the n, and when we are combining the two terms, we are using the or operation. That means what? It is obviously soft form. It is not a post form. So when we are getting the soft form, then we can easily understand how we can extract the mean terms. So when we are talking about the mean terms, that time always remember complement means 0 and non-complement means 1. So whatever a bar b bar is 0, 0. Here you can use plus, but plus is the standard. It's just we can connecting this one, this one, this one. So we are using the plus. It is not an operation plus. Okay. So a bar means what? A bar means 0 and b means what? 1. And here no complements are there. A b. So here I'm writing 1, 1. So what when this particular 0, here it is, when we are converting to the mean terms in the binary sequence, then it is 0, this one is 1, and this one is 3. That means what? These particular mean terms are true mean terms. So how many variables we are using? Two variables. If we are using the two variables, that time what happened? We are using this particular KMF, two variable KMF. So here I'm using two variable KMF, here A and B, and this one is 0, 1, and this one is 0, 1. So which one? Why we are using 1 here? Because what happened? This particular mean terms is present, so it is active as a 1. After that, what happened? This one is 1. 0, 1 means this one is the 1. Okay, so suppose what happened? I'm writing this way. This is the mean term 0. This is the mean term 1. This is the mean term 2. and this is the mean term is 3. You can denoting this way also. Okay. Now what happens 0, 1, 3? Which one is active? This one is active, this one is active, this one. So here I am putting here 1. Here also it is 1, here also, but here 2 is not present in the mean term, so here I am not denoting as a 1. Okay. So what happens? This particular C here, this particular second last, we have to look for adjacent square having ones. That is the mean terms adjacent to each other and combine them to form a square to eliminate some variables. So how we can, now what happened? To simplify the Boolean expression, we are making the group. Okay, and group is there, different type of rules are there. Always we can use horizontal when we are making the group or vertical. And always we are considering the adjacent cell. It is not like that we are considering, suppose this one is cell and we cannot make this to this one without avoiding avoiding this one. So this one is not neighbors of this one. So when we are talking about the neighbors, always we can consider this one. Yes, when we are considering this one, then you can consider this one also. Okay, and always remember, when we are making the group, we are not using odd number of adjacent set. We are using only even number of adjacents. That is also important. Okay, and diagonally we are not making the group. Diagonally we are not making the group. Okay, now what happened? And individually also we can make the group. Individually particular cell also making the group. That is also possible. Okay, now what happened here? 1, 1 is possible. We can make the group this way also. This is the one possibility. Individually we can make the group. When individually we are making the group, that time what happen? We are using more terms. So what happen? Whatever the expression you are getting from this one, your expression is wrong because you are violating the you are not follow the exact KMF rules. Okay, so what happen? Instead of this one, we can make this one as a group. We cannot consider this one because at a time we can consider only even number or adjacent cell. So this one is not an adjacent. If you are considering this one and this one is an adjacent cell, it is from a diagonal. So this is not an adjacent cell. After that, we can make this one. Okay, and when we are successfully constructing the group, that time what happened? Now we can go to the simplification of that particular expression. So suppose I am considering this particular first group, this one. That time what happened? This cell and this cell, how many variables are defined? Only one variable. So when it is 0 and this one is 0 and this one is 1. So what happened? 0 and 1 is cancelled. Only this particular part is remaining. So it is what? 0. So what happened? 0 means what? In mean terms it is a bar. So here I am writing a bar. And after that what happened? This particular group is over. We can consider a next group. This one, particular group. So here also 0 and 1 is, it is cancelled because opposite logic values are there. And when we are considering 1, 1 means what? In mean terms it is B. Because what when this particular 0 is lies in B and this particular 1 is lies in B. This particular 0 is lies in A and this particular 1 is lies in A. Okay. So when we are considering this particular vertical group, 0 and 1 is cancelled and here only 1 is remaining and 1 is representing B. And 1 means what? It is uncomplement from, so this one is B. Any doubt? Any doubt?
Sir, please explain this simplification.
Sir, can you explain it again?
Yes, simplification.
Okay. So from here you are getting this one. This particular part you are getting or not?
Yes, sir. Gotcha.
This particular part you are getting. Now what happened? How we are, why the KMF looking like this way? You can getting or not? Why it is 4 cell? Why it is not
Yes,
a
sir.
8 cell? You are getting, because we are using only two variables. So two variables means what? 2 to the power 2 means what? 2 to the power 2 means is 4. Okay. So here, how many cells we are using? Only 4. This one is 1, 2, 3, 4. 4 cells. And here only we are using, from this particular expression, we know that only two variables we are using. So here this one is A and this one is B. Okay. So what when this particular horizontally 0, 1, it is lies in B, and vertically 0, 1, it is lies in A. Okay. Now what when from the mean terms we are getting 0, 1, 3. So 0 means what? This particular cell we are considering as a 0. This particular cell we are considering as a 1. This particular cell we are considering as a 2. And this particular cell we are considering as a 3. You can write also mean terms, but when you are writing the mean terms, always remember it is right in the corner, at the lowest level of the corner. Okay, that means what? This one, because otherwise what when this one is class, because when the mean to which particular some particular cells are active, that time what when we are denoting as a 1. So always remember your mean terms number and your representation number may not be class. Okay, so always you can write the two mean terms in the lowest corner. Okay, suppose 0, 1, 2, 3. Okay, and also when you are combining the value of ABC here, 1 and 1, 1 and 1 means what? This one is 3, 1, 0 means this one is 2, and 0, 0, this one is 0, and 0, 1, this one is 1. Now, second thing is that why we are putting here 1? This one is 1, this one is 1. Why we are putting here 1? Because what happened? Based on the mean terms, from the expression we are getting the mean terms. This is the called what? True mean terms. So, which particular cell have a true mean terms? So, 0. So, what when 0 cells means what? Here, true mean terms are present, so we can active as a 1. Because we are deal with the mean terms. But when we are deal with the max terms, instead of 1, here we are using as a 0. Okay. Now what when again 1? This particular cell is active, so here what we are putting as a 1. And here no 2 is there, so what when we cannot put any 1 here in this particular cell. That means 1, 0 cell, we cannot put any mean terms because 2 is not present in the mean terms. But 3 is present as a mean term, so here we are putting as a 1. Now what when if you are, now next thing is that you can successfully assign the active cells by the logic value of 1 as a 1. Okay. Now when we are successfully assigning all those things, what is the next step? Next step is that to simplify the Boolean expression. For simplifying the Boolean expression in KMF, always you can properly construct the group of the cells. Okay. So always remember, individually, if you are considering the individual this particular making as a group, that time what happen? If you are suppose if you are using this one, we are making the group this one, and this one. Suppose we are using this one. That time what happen? What is the value of f? F value. F value is that it is a bar, b bar, a bar, b bar plus. If you are considering this particular cell, that time what happen? 0, 1. 0, 1 means what? A bar b, a bar b plus, again if you are considering 1, 1, 1, 1, because this is the individual group, cell number 3, that time what happen? 1, 1 means what? Plus AB. So what when something is wrong in KMF? Because what happen? Again what happen if we are using this particular expression is not a minimized form. Because what happen if you are using some particular exams rules here, see B and B is common. Okay, and if when we are a plus a bar, then we are getting some. So what happens? Something is wrong, because whatever expression we are getting from the KMF, actually we are assuming that that is the finalist minimized form. So something is wrong. Suppose what happens, instead of 1, 1, if we are making this particular group, 2 cells when we are combining, and 2 cell also even number, because only we are not combining with the 3 cell, we are combining only 2 cell horizontally. This is also valid group, and this is also valid group vertically. When we are combining this particular group, that time what happens? See here, this particular cell and this particular cell combined. That time what happened? This is the 0 and this is the 1. So we can cancel B. Only A is remaining. And what is the value of A? A value is 0 in this particular group. 0 means what? It is the A bar. So here I am writing A bar. If you are using this particular vertical group, this one, that time what happened? 0 is cancelled and 1 is cancelled. Only 1 is remaining. So 1 means what? It is B. And B, when 1 is uncomplement. That means we cannot use the B complement here. So here it is B. Now this is also correct. But what happened? We are using the KMF for minimization purpose. This is also correct and this particular expression are also correct. But when we are talking about the minimized concept, that time what happened? For based on the minimized concept, this one is wrong. Because why it is wrong? Because what happened? Here in this above expression we are using only 2 terms. But here we are using the 3 terms. Again, see each term only in the first expression, each term only one variable is there, one literal is there. But in the second expression, each term we are considering only 2 variables. So what happens when we are constructing the gates or logic circuit? That time what happens? More circuits, the more gates are required instead of this one, the first expression. So when we are comparing with the first expression, that time what happens? Here circuit, get number of gates and variables are less. So what happens? This one is the correct. Are you getting or not?
Yes, getting, sir.
Yes, sir.
Okay. Okay. Now what happened? How we can consider this one? This particular example. You can try yourself. Because if I am continuously explaining, you are not doing anything, that time what happened from your side? You are not getting. Okay. So how we can do this? So can you tell me this particular expression, this particular function, how many variables we are using? How many variables we are using?
3 variables, sir.
3 variables.
Correct.
3, sir.
Then how we are designing the KMF? How many cells are required in this particular KMF?
8. 8, sir.
8. Correct. Correct. Okay. Now at first what happened? Before going to the constructing the KMF, now can you extract the mean terms from this particular expression? What is the mean terms? Because this is the soft form. Okay. So this is the soft form. So what is the mean terms of this particular expression? Can you tell me? So this one is what? 0, 1, 0. 0, 1, 0 means what? 2 is present. Yes or no?
Yes, sir.
2 is present. 0, 1, 0. Sorry, this one is 0. Sorry, 2 is, yes, the second term is true. 2. Okay, 0, 1, 0. 2 is present. First term is what? 0, 1, 1. 0, 1, 1 means, 0, 1, 1 means what? It is 3. Okay. This one is what? 1, 0, 0. 1, 0, 0 means what? 6. 6 or no, 1, 0, 0 means 4. Sorry. Yes or no? It is 4. Because x is 1, y bar is 0, and z bar is 0. So 1, 0, 0 means 4. And the last term is what? 1, 0, 1. That means what? This is the 5. Now we can easily draw the KMF. So how we can draw the KMF? Three variables we are using. So this one is the and here suppose we are not using, we are using xyz. Based on the expression we are here, this one is the x, this one is the yz. Because here not using ab, so they are using xy, small letter x and y. So here I am using xyz. So that means what? This one is 0, 0. just you assign the value 0, 1, 1, 1, and this one is 1, 0. And this one is only one variable, so just you can put as a 0 and 1. So whatever the min terms are generated, this one is 0, this one is 1, this one is 2, this one is 3, this one is 4, this one is 5, this one is this one is 6, this one is 6, and this one is 7. Okay. Now what happened? Which particular we are assigning one, which particular cell we are assigning one, those particular two min terms are present. So 2 means what? This one is 1. 3, so this one is 3, so 2 min terms is gone 3. 4, which 4, this one is 4, and after that 5. Now how we can make the group? So making the group means, see here, we cannot use this particular diagonal group, or we cannot make this one as a group. And if we are considering the always you remember your main objective is that to make the large group. Okay, if you are considering only small group, that time when there are many terms are created in the expression, many literals are created. Okay, after that what happen, your expression is not a minimized form. Why we are using this particular K-map? That means our main objective is that we are minimizing the expression, minimize. So what happen? How we can make the group? It is very easy, because this one, see, for this particular example, it is very easy. This one is the group, and this one is the group. Yes or no? Or any other one? Any other one is there? No. So what happen? When you are simplifying this particular expression, then what it is you are getting? Suppose I am considering this one is the f. That time what happen? If you are considering this particular expression, this particular group, that time see here 0. Only this same particular row, same particular column we are using. This particular same particular row we are using. So x value is 0. So this one is x bar. This one is x bar. Okay. Now what happened? This is the x bar. What about the yz? See here 1. You can maintain the place. Which particular place? You can consider only a particular place. The opposite place we cannot cancel. This is 1 and this is 0. So we can cancel this one. And only 1 is left. So 1 means what? It is y. It is not a z, because this one, the first bit is y and second bit is 0. So y means what? Y value is 1. So whatever, this one is 1. This group is over. When we are going to the next group, see, this one is the next group. Here x value is what? 1. So here I am writing here x. And after that we are considering this sequence, this particular cell, because we are considering this particular group. Okay. So what happened? Here 0 is, the second bit is 0, and the second bit of the other cell also 1. So 0, 1 is cancelled. Remember one thing, when we are considering the two cells, when we are grouping the two cells, always one variable is different according to the properties of K-map. So here it is successful. So 0 and 1 is the only one variable, and 0, 0 means what? Y value is 0. So y value is 0 means what? Is the y bar. Now what happens, if you are using any exams rules or any Boolean algebra rules, you can get the same expression, because this one is the ultimate minimized. Are you getting my point? Suppose I'm using some particular other how we can make the group? Okay, I'm some basic concept we will discuss. Suppose this is the 3 variable K-map. Suppose this one is 1, this one is 1, this one is 1, this one is 1, and this one is 1. So how you can make the group? This way also correct. You can make this one. This way also correct. and after that this way also correct. But whatever the expression is generated, that is not a minimized form. Why? Because whatever 1, 1, 1, 1, it is four cells we can combine together at a time. And this one is okay. So whatever, this particular cell is correct. Okay. Another important thing, always remember, see here, if you are considering this particular 0, 0 and this particular 0, 1, 0, that time happen, how many variables are defined? See here, 0, 0 and 0. And next one is what? 0, 1, 0. 0, 1 and 0. So I'm talking about the last one, last cell and the first cell. This particular cell and this particular, and how many variables are defined? Only one variable. So that is also satisfied. That means what? The last and the first group also we can combine. Though it is not a neighbors, but it is that means only one variable is defined when we are comparing the two cells. Always remember, when we are comparing the two cell, that time what happened? Only one variable is defined. When you are using the four cells, that means two variables are defined. So what happened? When we are comparing the first and last cell, only one variable is defined. So also it is correct. So some particular cases, what happens? Suppose what I mean to say, suppose this one is 1, this one is 1, this one is 1, and this one is, suppose this one is 1 and 1. Suppose you are making this particular group, you are making this particular group, and you are making this particular group. That time what happened? From this one particular terms are created, from this particular group also one particular terms are created, and with this particular group also another terms are created. So when we are writing the expression, that time how many terms are there? 3 terms are there. This one, and this one. If instead of this one, if I'm using, suppose I'm using just a minute. If I'm using, suppose this one is 1, this one is 1, okay, this one is 1, this one is 1, no, whatever, suppose this one is 1, this one is 1, okay. So what happen? If I'm using this particular group, this one as a group, and instead of making this particular group and this particular group, if I'm considering only two groups the same way, this is the one and this is the one. That time what happened? How many terms are coming? From this and this, only one terms are created. Okay, only one particular terms are created, and for this one, horizontally, other terms are coming. Only two terms are enough. So what happened? Our expression is proper Boolean. Our expression is the minimized. So if you are not using this way, this particular left hand side and the rightmost side, if you are not grouping at the same time, that time what happen? If you are making the two different group, that time what happen? Your maybe one particular terms are extra created. And how when we are making that leftmost side and grouping leftmost side with the rightmost side, it is not like that. Suppose what happened here, it is suppose this one is suppose just a minute. You cannot use suppose what happened this one. Just a minute. Suppose this one is 1 and this one is 1, or whatever the other cells, whatever this one, or this one. That time what happened? You cannot consider this one and this one, because what happened? It is not matching. Here it is 1, but here both the variables are 1, 1. Okay, and what happened? Suppose in the 4 variables, sometimes what happened? This one is 1, this one is 1, this one is 1, and this one is 1. Then you can consider as a one group. This one is one group. This one is 1. This one is, it is making only one group. Okay, but here it is 1 1, but here it is not a 1. Suppose 1 is not present here, so you cannot make the group. So you cannot combine with this one and with this and this. And suppose always remember, this way we cannot make the group vertically. And suppose what happen, it is not like that in 4 variable, we cannot combine with the only 3 cells. We can combine either 4 cells, 2 cells, 8 cells, something like that. Because what is the reason, logic? Because what happen, always we can 2 to the power something. So 2 to the power something means what? Always it is the even number. So 2 to the power 1 means 2, to the power 2 means 4, to the power 3 means 8, to the power 4 means something like that. So we can maintain, this is the main concept. Okay, are you getting?
Yes, sir.
Yes, sir. Yes, sir.
Okay, and easily you can do this one. This one is also very simple. Just a minute. You can try second example. How much time right? Or 10:41. Then we have a time. You can try for this one. The second example. Reduce using KMF expression 2, 3, 6, 7, 8, 10, 11, 13, 14. You can try and tell me the final answer. Fast. This one. Yes, 2, 3, 6, 7, 8, 10, 11, 13, 14. Now, how many KMF variables we are using? 4. Yes, 4 variable KMF we are using. So you construct the KMF and assign the logic value. Okay, you can consider any variable. You can consider X, Y, Z, P, Q, R, S, T. You can consider A, B, C, D. Okay, because here we are not using any standard variable here. But when the question is especially mentioned some particular variable, like the second example, f, x, y, here we are using small letter x, y, and z. So what happens? When you are assigning when you are constructing the KMF, that time also you can use the same variable. Okay, here we are using x, y, z, but you are using p, q, r, s, t. Then it is defined. Okay, the whole your answer is wrong. So you can just very careful about this one also. And try me, tell me the answer.
Sir?
Yes.
Sir, A complement, B complement, C D complement,
A complement,
B complement, C D complement,
A complement, C complement, है ना?
B complement, A complement, B complement, C फिर D complement.
No, your first term is wrong. And second one, second term?
Sir, A complement, B complement, C D complement.
No, wrong.
Sorry, not D complement, C D.
No, wrong.
Yes, sir.
How many terms are coming? Can you tell me how many total terms are created?
Sir, wait, I will check once again.
Anyone? Yes, you can try. At least you can try. It is good. Okay. When you are practicing too much, then you can automatically understand. It is no problem. First time you are constructing the group, you have some particular doubt, so some problem. So it is the first time. It is no problem. Anyone can get this particular expression? Anyone? क्या है कि नहीं, क्या सोच रहा है कि आप लोग क्या कर रहे हैं भगवान ने दो एक लड़का को छोड़ के?
Doing sir.
Suppose I am writing here AB. Okay. AB गलत होगा, गलत होने से कोई प्रॉब्लम नहीं है. गलत तो क्या फर्स्ट टाइम में करेक्ट होगा क्या कोई विशेष? कोई प्रॉब्लम नहीं. 0 0 0 1. Okay. 1 1 1 0. Okay. Then after that again I am writing here 0 0. And this one is 0 1 1 1 1 0. So here I am writing here this mean term. You can write always. It is better. You can very easy. You can write. It is a systematic. You can write always mean terms at first 0 1 2 3. So when you are assigning the one, it is very easy for you. It is the good habit. Okay. 0 1 2 3 4 5 6 7 8. Okay, 9 10 and 11 12 13. You can try. 13 14. मेरे लिए वेट मत कीजिए, आप लोग कीजिए. 14 15. Now 2 is 1. According to the question, 2 is the true mean term. 3 is the true mean term. 6 is the, where is the 6? 6 is the true mean term. 7 is the true mean term. Okay, good. 8 is the true mean term. Where is the 8? 8 is this one. 10 is the true mean term. Yes, it is good. 11 is the true mean term. 13 is the true mean term. 14 is the true mean term. Obviously, this group is, we can consider. This is a large group. Yes or no? Yes or no?
Yes, sir.
After that, this one we can consider. At first, your objective is that find out the large group. बाद में बाकी सब देखना है आपको. और कोई large group बना सकते हैं यहाँ पे. ये हम लोग बना नहीं सकते हैं because the cell number 9 is not present. Okay, 15 also not present. But here 1 1. So instead of we can make the cell number 11 10, can we make this way? This one at the same time, same group. Okay. ये हो गया. Then another one we can make, this one is 1 and this one is 1. We can make as a single group, but they have a problem. Here we can, here 1 is not present. Okay, but we can make the group this way also, because yes, this one is 0, this one is 0 means here 0 is not present. This group here 5 is not, so individually there is no option, because here 15 also there is no one, so this individual group is possible, this one. Otherwise we have an option, but this one we can make, how we can make individual individual.
सर 8 और 10 को ग्रुप किया जा सकता है क्या?
8 और
10 लास्ट वाला,
लास्ट वाला किसके साथ?
एकदम लास्ट के साथ 8 and 10.
8 10 अच्छा, यहाँ पे 0 नहीं है ना, यहाँ पे हाँ 8 और 10 को हम लोग कर सकते हैं, 8 और 10 को हम लोग कर सकते हैं. Now we can find the expression. This one is earlier what happened, see here, here some particular, if 4 variable, suppose what happened here, it is some here it is some particular, suppose this one is the, here it is 1, here it is 1, but here it is nothing, here it is 1 and here it is 1. So we cannot make this way group, because what happened, why it is not possible, because what happened here, it is not a 1, but we can individually we can consider this one and this one. This one is possible. So here I am writing this one and this one. So when you are constructing successfully, that time what happened? From every group, how many groups are there? These are how many terms it is coming. For this one, it is 1. This one and this one is 2. This one is 3. This one is 4 and this one is 5. 5 terms are coming. Okay. And when we are using the large group, we are getting the small number of variables or literals. And if we are using only 2 groups, that time what happened? We are getting a small number of variables, but it is large compared to the 4 groups when we are constructing the 4 groups. But when we are constructing the individual group, that time what happened? It is that particular term, whatever term is generated, the variables is more variables are present within that particular term, because what happened here, we are using only one group. Okay. So if you are writing the expression of this one, that time what happened? AB is 1 1. So here I am writing AB, and here it is 0 1. So 0 means what? It is C bar, and it is D. See how many variables are coming? All the variables are coming. So always remember, the worst condition we can constructing the only within the group, because in this particular example, see here, if you are not grouping one is an individual, there we have a no other option. So this particular terms always it is coming. Okay. But your main target is that always making the large group. Okay. Without violating the KMF rule. So there are many examples are there, and tomorrow I will discuss how we are using the don't care. Okay, because today I'm so tomorrow I will discuss the don't care and how we can use the KMF with that with the don't care. Okay. After that, we are going some another technique. Okay, that is called a Queen-Max-Lucy method. And when it is over, then we are going to the directly combinational circuit, how to design the combinational circuit. Okay?
Yes,
okay?
sir.
Yes, sir.
Okay, thank you.